These are the frequently asked questions for Algebra 2 for section 7.5, day 2, where we are solving exponential and logarithmic equations. Number 31 says the equation y equals 6.72 times 1.014 to the x models the world population y in billions of people. That's going to be important later on. X years after the year 2000. Find the year in which the world population is about 8 billion. Well, the formula is already written in billions, so we just need to put an 8 in for y. And then we do not want to graph this. So what we want to do instead is solve. And to solve it, we would first divide both sides by 672. And that's because we need to isolate that exponent. So 8 divided by 6.75 equals 1.014 to the x. Two things to notice at this point. First of all, I did not punch in 8 divided by 6.75. I want to avoid a rounding error if at all possible. So what I do now is think, how do I get rid of that 1.014? Well, that's a base for an exponent, which means I need to take a logarithm to get rid of it. I need to have my logarithm base match my base. So whatever I do to one side, I have to do to the other, just like any algebra that we would have. These will drop right out. And what I really need to punch in is over here, and that is the logarithm of 8 divided by 6.75 divided by the logarithm of 1.014 using the change of base formula, the logarithm of the number you're trying to evaluate divided by the logarithm of the base. And then we would grab a calculator and see what we get. So we'd punch in the logarithm of 8 divided by 6.75 and then finish off the parentheses. And I generally will press enter at that point and get an answer. And then I want to divide that by the logarithm of 1.014. Again, finish off those parentheses. The calculator really likes it when you do that. And that comes out to 12.22039816, so approximately 12.2 years. And we didn't have to graph, and we didn't have to mess with the window, and we were able to get a really nice answer. Now, it says find the year in which the world population is about 8 billion. So what I have to do is figure out where's that starter year, what was the 0 year here, and that was 2000. So sometime during 2012, that should reach 8 billion. Next one on my list here is 35, and for problem number 35, we have the logarithm of x plus 4 equals 8. Well, before you can snail shell, what you have to do is have that logarithm isolated. So we're going to go ahead and subtract 4 from both sides, and we'll have the logarithm of x equals 4. And now, like I said, snail shelling is a technique you use for what's called exponentiation. We're going to take this logarithm and we're going to write it as an exponent. So this would be 10 to the 4th equals x when you make that snail shell pattern. And then, of course, you just plop the zeros on there to get your x value. Easily checkable. Punch it back in the calculator and it's logarithm base 10, so you do logarithm base 10 of 5 minus 2 times 10,000, and that would get you number 35. Number 37 has 3 logarithm of x equals 1.5, so I need to get my logarithm by itself. That means that 3 has to go. We're still working on isolating. So divide both sides by 3. The logarithm of x equals 0.5. And then, again, we need to exponentiate, which means we need to snail shell this. So this would really say 10 to the 1/2 or 10 to the 0.5 equals x. And that's actually the square root of 10. They wanted this to, they did not say how many decimals, so really we'd be okay writing the square root of 10. Because anything to the 1/2 power is its square root. So there's 37. 38, we get a feel for the fact that we need to isolate that logarithm. So the 2, have to get rid of it. We're going to have to divide both sides. Then we need to write down what our base is. In this case, this is a base 10 logarithm. And snail shell, exponentiate. So 10 to the 5 halves equals x plus 1. And then again, no rounding error, just go ahead and subtract 1 from both sides and then punch it in. So 10 to the 5 halves minus 1 equals x. So 10 to the 5 halves, and then we need to subtract 1. 315.227766. So x is approximately 315.2278 with rounding. So there is number 38. Now, where to next? Number 41. We have some problems that just say solve each equation. That looks too much like 44. I need to write slower again because the smartboard's not keeping up with me. This would be the logarithm of 2x plus the logarithm of x equals 11. We have to condense. When we snail shell, we need to have one logarithm on each side, if there are more than one. Otherwise, we just want one logarithm on one side and then a number on the other side. So addition means multiplication. This was really the logarithm of 2x times x equals 11. And that's the logarithm of 2x squared equals 11. And then again, common logarithm, log is base 10, and snail shell. So 10 to the 11th equals 2x squared. Then we would go ahead and divide both sides by 2. So 10 to the 11th divided by 2 equals x squared. And then we would take the square root of both of those. And we would have a positive and a negative. But again, we know we're really only interested in the positives here since this is a logarithm. And then we would get, let's see, this is a wonderful answer here. This is approximately 223,606.8. Right there. All right, the next one I had is still up here, so I will erase this problem and go after number 44. That looks kind of fun. So 44. As I'm writing it down this first time, I'm going to go ahead and put that power back up. Remember, multiplication comes from powers, so that's the logarithm of x to the third minus the logarithm of 6 plus the logarithm of 2.4 equals 9. Now we go ahead and make any of the subtraction, division, and any of the addition, multiplication. So that'll be the logarithm of x to the third over 6. And now notice there's no parentheses there. And we have a plus for the 2.4. Well, that means that's multiplication. So we're going to put that up there with our x to the third. And then 2.4 divided by 6 is 0.4. So this is the logarithm of 0.4 x cubed equals 9. And again, we would go ahead and exponentiate, which means snail shelling. Common logarithm, so 10 to the 9th, 10 for our base, equals 0.4 x to the third. Then we would go ahead and divide both sides by 0.4. And that would give us x cubed. And then finally, we would take the cubed root to get our answer. So let's see here, 10 to the 9th divided by 0.4. And then we need math button. Cubed root, remember, is number 4. So that is 1,357.208808, and Your book just chose to go to the nearest tenth on this one. Kind of interesting. Again, usually we will do 10,000ths with these problems. So I'm going to go with 10,000ths. They're kind of all over the map here on how many decimal places they want you to go with your answers. 47 says, consider the equation 2 to the x over 3 power equals 80. And A says, solve the equation by taking the logarithm base 10 of each side. Now, you haven't seen me do this before because I really don't like this method. It's not that it doesn't work, it's just that it's not intuitive. And math to me should be logical and intuitive. So if we want to get rid of the 2, we should take logarithm base 2. However, here's something else that we can do. So we have 2 to the x over 3 power, and then we have 80. What we would do is take the logarithm base 10 of both sides. Now, if you're thinking, what on earth are we supposed to do now? We still have the x over 3 up there. Well, now it's a power. So we can bring that power out in front and make it multiplication. And then we can divide both sides by the logarithm of 2. And we will have x over 3 equals the logarithm of 80 divided by the logarithm of 2. And then we would multiply both sides by 3. And then we would grab our calculator and see what we get. So, logarithm of 80, parentheses, divided by the logarithm of 2, parentheses, times 3. And that is 18.96578. So 18.9658. So again, not as natural as I would like it to be. It's definitely a way that you can solve these problems. But like I said, it's just not intuitive. So B says instead, now do what I've been teaching you, which is to match your bases, use inverses. So the logarithm base 2, and these will drop out, and you'll have x over 3 equals, and then use your change of base formula. And then we would multiply both sides by 3. So x would equal 3 times the logarithm of 80 divided by the logarithm of 2. And if you are feeling like you've got a little bit of deja vu action going on right now, you would notice, hey, that's exactly what we had when we did it with base 10 over here. And that is 18.9658. Part C says, compare your result in Part A and Part B. What are the advantages of each method and explain? All right. So, for Part C, both methods work. All right. Advantage of taking the logarithm base 10. Logarithm base 10 is right on your calculator. So we have common logarithms on our calculator. However, like I said, I would choose logarithm base 2 because it is more intuitive and logical. And that's just a matter of preference. I do know some of the teachers here at Upper High School teach logarithm base 10 for just about everything. So it's just a matter of what you like. what you're used to, what's easier to remember. All right, number 49 says, as a town gets smaller, the population of its high school decreases by 6% each year. Well, it's decreasing, so right away, I'm thinking about that formula because that was our depreciation formula where things are going down. The senior class has 160 students now. In how many years will it have about 100 students? So what I'm going to do first is I'm just going to write the model. And they started with 160 students. And it's going down by 6%, so that means we have 1 minus 0.06. You can think of that in terms of money. If you have $1 and you subtract 6 cents, now you have 94 cents. But then we want to know when will they have 100 students. So that's when y equals 100. Oh, I probably should have kept my 0 up here as well. All right, so what to do? We need to get rid of that 160. We have to isolate our base. So divide both sides by 160, and we absolutely could figure out our 100 divided by 160 as a decimal in this case, and just work through it that way, 0.625. And then we need to take the logarithm of each side. So let's take the logarithm base 0.94 and get rid of that. And we'll use the change of base formula over here. So logarithm of 0.625 divided by the logarithm of 0.94. And that will give us our time. So punching it in, logarithm of 0.625 parentheses divided by logarithm of 0.94 parentheses. And it's 7.59596, so the time would be approximately 7.6 years. And let's go back and see if they wanted to know what year. In how many years will it have about 100 students? Well, then we're done, because it's about 7.6 years. You could say about 8 years. Both of those would be good answers, because again, this is an estimate, so we want to treat it that way. All right, next one. Number 50, solve each equation. 2 to the x equals 1/2. Now these were meant to do mentally. It says mental math over here. So the 2 hasn't changed, but suddenly it's a reciprocal, and that means x was -1. They didn't raise it to any other power, meaning there's no number other than 1 to go along with that, because it's still just 2 to the first. But the negative definitely will flip that and give us the reciprocal. So in number 57, I look at that one and think, okay, got it, gotta be a negative. Has to be. And it does. It has to be a negative. So x is going to be negative something. But then I think, should snap a -1 there. Then I think, well, how do you get 25 to be 5? What kind of power do you raise 25 to be 5? That's square root. Yeah, and square root is the 1/2 power. So it would be x to the -1/2 for number 57. So all of these problems here, 50 to 57, are meant to be mental math where you can reason your way through them. Watch for the fractions. You know, if you see those reciprocals, that you have a negative as part of your power, and then just think, what do you do to the number to get the number that is in the problem itself? Number 66, it says solve each equation, if necessary, round to the nearest 10,000th. So with number 66, I notice I have 2 logarithm statements, and if I'm going to solve that, I need it to be 1. So I'm going to put those powers back up where they belong, and that'll be the logarithm base 3 of 2 to the 4th minus the logarithm base 3 of x squared equals 1. And then 2 to the 4th is 16, so that'll be the logarithm base 3 of 16 minus logarithm base 3 of x squared equals 1. And then subtraction is division, so this is the logarithm base 3 of 16 over x squared equals 1. And then I now have this all as one logarithm statement, which means it has been condensed. I just need to snail shell this, which again, fancy name for it is exponentiate. So 3 to the first is 3. 3 equals 16 over x squared. Now, you can't have what you're solving for in the denominator, so easy thing to do with this one would be to just write 3 over 1 for 3, and then cross multiply. That'll make this go a little bit faster. So we multiply 3x squared equals 1 times 16, which is 16. Divide both sides by 3, and we have x squared equals 16 thirds. Now we need to take the square root of both sides, and again, normally we would say, hey, let's do both the plus and the minus here, but we need to think back here for number 66 at the original problem and think, would it be okay for us to put that back in there? Well, we'd be taking the logarithm base 3 of a negative number if we do that, and that isn't going to happen. So we ignore the fact that there's a negative here and just keep going after our positive answer. And that will be the square root of 16 is 4 over the square root of 3. Then we would go ahead and rationalize the denominator, and we would get 4 square roots of 3 over 3. But they did tell us we could go ahead and round this to the nearest 10,000th, so we could just punch in 4 divided by the square root of 3 anyway. So x is approximately 2.3094. The next decimal we see there is 0, so we will keep that 4 as is for that problem. All right, I had one more in mind here, but I know I'm going to have to do some erasing because that took up a lot of space. So let me get back up here and go after number 74. 4 to the 3x equals 77.2. Well, I certainly could write 4 as 2 squared, but then I think 2 to some power is going to come out to 77.2 really nicely. No, it isn't. So instead, just make a little room here to take my logarithms, and I will need to take the logarithm base 4 of both sides. These will drop out because they're inverses, and 3x equals, we'll use the change of base formula, the logarithm of 77.2 divided by the logarithm of 4. And then we would divide both sides by 3, and we'd grab a calculator. To avoid any rounding error, we'd punch this all in at once. So we need the logarithm of 77.2 parentheses divided by the logarithm of 4 parentheses, and then divide that entire answer by 3, 1.04508, so 1.0451 for number 74. And those are the only problems I'm going to do on this assignment.